In this video, we are going to look at the conjugate of a surd and rationalizing the denominator of a surd. So, the conjugate of a surd is defined as follows. So, if given a surd root A plus root B, the conjugate is defined as, let's call this expression S for surd and S subscript C is the conjugate root A minus root B. So to find the conjugate of a surd, you just simply swap the sign. That's it. Swap the sign. Swap the sign. Let's look at an example of rationalizing the denominator of a surd using the conjugate. So root 5, 3 root 5 plus 2 root 10 all over 5 root pi plus 6 root 11. So using the fact that if we multiply this expression by the conjugate of the denominator, there's a reason why we multiply by the conjugate of the denominator, because something special happens when we multiply by the conjugate of the denominator. We could have just multiplied this expression by the denominator, but the special something would not happen. But look at this. So 5 root pi plus 6 root 11 all over, this is supposed to be minus, my bad. Fill in black. Here we go. Orange pen. So minus by all over 5 root pi minus 6 root 11. So notice multiplying this expression by the next expression over here, this expression over here is still mathematically the same as multiplying by 1 because the numerator is the same, the denominator is the same. So let's expand. So we take in this, multiplying it by that, and usual expansion. So let's keep track of this. So 3 root 5 multiplied by 5 root pi. So let's multiply the coefficients of the surds. So 3 by 5 is 15, and root 5 by root pi is just root 5 pi. Now 3 root 5 by negative 6 root 11 is, we're looking at the coefficients of the surds first being multiplied, so we'll have 3 by negative 6, which is negative 18. And now considering the surds, root 5 by root 11, or we would just get the square root of 55. 5 by 11 is 55. Now with this one, same expansion laws, so 2 root 10 by 5 root pi is, looking at the coefficients of the surds, 2 by 5 is 10, so plus 10. Root 10 by root pi is root 10 pi. The reason why I use pi in my examples is just to drive the point of the concepts and the algebra involved. I could have been normal and use a real number instead of a irrational number, but it's just to drive the point across. Oh, and a surd could be the square root of an irrational number too. Like, all irrational numbers are technically surds. No, some irrational numbers are surds. Could be expressed as surds. That's the correct statement. So now 2 root 10 by negative 6 root 11. Looking at the coefficients of the surds, 2 by negative 6 is negative 12. And root 10 by root 11 is root 10 by 11 is 110. Now for the denominator, 5 root pi by 5 root pi is 25 pi. Five root pi by negative 6 root 11 is negative 30 root 11 pi. 6 root 11 by 5 root pi is positive 30 root 11 pi. And 6 root 11 by negative 6 root 11 is negative 6 squared root 11. There's a reason I expressed it like this. I should have, let me just, so 5 root pi by 5 root pi is 5 squared. Yeah. So this and this would just cancel. So you could simplify the top, but we'll just leave it like that. Okay, let's simplify the top a bit. So we get 15 root 5 pi minus 18 by 11, no, 18 by 5 plus, this would just be 10 root 10 pi minus 12 square root of 110 is 11. No, that would just be square root of 110. And the denominator would just be 5 squared minus 6 squared. Now, the whole point of illustrating this is that when you're rationalizing by multiplying by the conjugate of the denominator, there would be a result that you would just end up with. If this was denoted by square root e plus square root b, and this was square root again a minus now the square root b. So when you take the product of a surd and its conjugate, this result, as shown here in the example, is an important result to commit to memory for questions with surds. So that would be it for rationalizing by multiplying the expression by the conjugate of the denominator.